order to design our system so that the effect of noise is mitigated, we need to know what we're dealing with. So let's spend the next couple of classes talking about noise. The mathematical features of what noise is. Basically, noise is a Gaussian random process. So, who can tell me what a random process is? Have you ever heard the term random process? Maybe? No, not really? Okay, a random process, I don't really expect you to know what a random process is because you might not have run into it yet. But basically, a random process, a discrete time random process, is merely a sequence of random variables. Where the sequence is with respect to time. So in other words, let's say we have a random process, let's call it capital X of t. Discrete time, square brackets. So in other words, for each t, capital X of t is a random variable. So a simple example of that would be at each time, roll a fair die. So at time 1, I roll a fair die and I write it down. At time 2, I roll a fair die and I write it down. And so on. So the sequence, the random process x of t would just be the sequence of all of those die rolls. So I could do that once, and I could get the result 3, 1, 2, 5, 6, 2, 2, and so on. I could do it another time and get 4, 3, 5, 2, 1, 1, 4, and so on. The idea here is that at each time, at each time, the outcome of the experiment is random. So at each time here, it's a random variable. So in this case, what I could say is, what's the probability that x of 3, so at time 3, what's the probability that that's equal to 1? So in other words, if this is time 0, 1, 2, 3, 4, 5, 6. At time 3, I have potentially the outcome of a fair die roll. So what's the probability that at time 3, that result will be equal to 1? So remember, at each time, I'm rolling a fair die. So at time 3, I rolled a fair die. What's the probability that that comes up to be a 1? It's just 1 over 6. So basically, the idea here is that at each time, I have a separate random variable. So it's just a sequence of random variables, that's all. So if I tell you a time, then you have a probability. Now, because this is a sequence of random variables, what we can do is we can write down excuse me, we can do everything that you can do with any set of random variables. So for example, we can write down joint probabilities. So remember we talked about joint probability. That's basically the probability that two events happen coincidentally. So for instance, I could talk about the joint probability P between x at 1 and x at 4. Okay, so these are separate die rolls, so they are likely to be what? What's the special term that we use for? Independent. They're likely to be independent, in which case this joint probability is going to be equal to what? Yeah, more generally. So how would this formula look?
1 by 6 into 1 by 6?
Actually, what I'm going for is this. It's the product of the two. Yeah, but in general, if it's a fair die, then all of the outcomes here are probably 1 over 6, and all the outcomes here are probably 1 over 6. So in other words, if I had P of x at 1 equals 3, x at 4 equals 5, this would generally equal to 1 over 6 times 1 over 6, 1 over 36. Okay, this need not be true. It need not be true in order to have a random process that they're independent. You could have dependence. So generally, you could write down not only two-fold joint probability, you could write down threefold. You can relate 3-time instance at the same time, 4-time instance. This we call the second-order statistics. Of the random process. If I had 3-time instance, we would call that third-order statistics. 4 of them, we call that fourth-order statistics, and so on. Okay, so much like I did last time, we can do mean and variance of a random process, but now they're functions of time. So mean and variance. Before I get into this, let's look at another example. So, random process need not be defined as homogeneously as I just did. We could have a different example that's like this. E.g., x of t is a function of outcomes of a fair coin. But if let's say that at each t, we flip a fair coin. Then, if heads, then x of t is 0. And if tails, then x of t is equal to t. So what would that look like?